Welcome to another video on illustration on the additive model. So in a previous video, we used the method of moving average to find a seasonal index or the seasonal variation, and we deseasonalize the data. In this illustration, we are going to use the other method, that's the linear regression method, to find a seasonal variation or the seasonal index. So the table below shows the sales of new cars by quarters during a period of 3 years. So we have the year and we have quarters. Using the linear regression method, that's we have to use additive model, determine the deseasonalized sales and establish the trend equation. Estimate the sales to be expected for the quarters of 2017. So solution, we have a year, we have a quarters, 2014 quarter 1, quarter 2, 3, 4. Then for 2015 to we have quarter 1, 2, 3, and 4. And 2016 we have quarter 1, 2, 3, and 4. Then we have our sales. So let's say our sales values are Y, 55, 76, 61, 77. Then for 2015 we have 54, 65, 52, 81. Come to 2016, we have 59, 83, 68, 78, 93, 93. So with the method of the regression equation, we have to, so let's find our t. So this is our t, starting from 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, and lastly we have the 12. Okay, so now let's find our equation first. So first let's find our equation which will help us to determine the trend. So our equation is giving y is equal to a plus bt. We want to find the trend values. So let's say the trend values is y. So using your calculator, you can easily find the values for A and B. So now let's find the values for A and B using the calculator. I've already uploaded a video on how to use the calculator to find the A and B. So the value of A is 56.5909. Then the value of B is positive 1.9860. So this T be used to determine the trend values. We're going to use this to determine the trend values. So these are trend, that's YE, that's the trend. So given that T is equal to 1, we will have to put T in this equation to find the trend values. So given T to be 1, our trend values for the first quarter in 2014 is 58.5769. Then given T to be 2, our trend value 60.5629. So you would have to continue in that order to the last end. Okay, so your trend values, after getting your trend values, the next thing you will have to find is your seasonal index or your seasonal variation. And under the additive model, your seasonal variation is given by your actual y minus your trend values. So now let's find our seasonal index, or you can say specific seasonal index. So for the first one, we have 55 minus 58.5769. So unlike the previous example we solved where we had a moving average, you see that for the trend value for the first two, we had nothing here. That's one disadvantage under the using the moving average. The extreme ends values are eliminated, but we don't have values for the extreme ends. But if you are using the method of regression, see that the extreme ends are being filled. So we have 55 minus 58.5769, giving us negative 3.5769. Then 76 minus 60.5629. So have 15.4371. Next one is 61 minus 62.5489. negative 1.5489. 77 minus 64.5349. 12.4651. 54 minus 66.5209. Negative 12.5209. 65 minus 68.5069. Negative 3.5069. 52 minus 70.4929. Negative 18.4929. 81 minus 72.4789. 8.5211. 59 minus 74.4649. Negative 15.4649. 83 minus 76.4509. 6.5491. 78 minus 78.4369. Negative 0.4369. And lastly, 93 minus 80.4229. 12.5771. So after finding the trend values, we have to find the average. We have to find the average of this seasonal index. So that becomes, then after finding the average, we also have to adjust it. We also have to adjust it. So we have the ASI, the average seasonal index. So now let's create another table here. So seasonal index. So we have the year and we also have the quarter. We have 2014, 2015 and 2016. So we have quarter 1, quarter 2, 3 and 4. Then we also have our total here. So for the first quarter in 2014, let's go up. For the first quarter in 2014, we had seasonal index of negative 3.576. Negative 3.5769. Then for the second quarter in 2014, we had 15.4371. And for the third quarter, we had negative 1.5489. And lastly, 12.4651. When you go to 2015, we had the first quarter to be negative 12.4651. Negative 3.5069. 69, negative 18.4929. Then for the last quarter in 2015, 8.5211, 8.5211. Then let's come to last year, that was year 2016. For the first quarter, negative 15.4649, 6.5491, negative 0.4369. And lastly, we have 12.5771. Now let's find the total and we go ahead to find the average. So the total, then we also have the averages. So the average. So the first one is negative 3.5769 minus 12.4651 minus 15.4649. The total of negative 31.5069. So the average is divided by 3, which is giving us negative 10.5023. Let's go to the second one. 15.4371 minus 3.5069 plus 6.5491. Total of 18.4793 and an average of 6.1598. So for the third one, negative 1.5489 minus 18.4929 minus 0.4369. Negative 20.4787. Also an average of negative 6.8262. Next one is 12.4651 plus 8.5211 plus 12.5771. 12.4651, 8.5221 and 12.5771, giving us a total of 33.5633. Then an average of 11.1878. So when you're done finding the average, the next thing we have to do is to find the summation of the average if it's giving us 0, since we are dealing with the additive model. So the first one is negative 10.5023 plus 6.1598 minus 6.8262 plus 11.1878 giving us a value of 0.0191, which is not equal to 0. So we need to bring it to 0. What do? We have to find the grand average. The grand average, which is 0.0191 divided by 4, giving us 0.0047775. Since it is positive, to bring this value to 0, we need to subtract. So average minus the grand average, which gives us the what? Adjusted seasonal index. 0.00475. So the first figure was -10. So -10.5023 minus 0.004775, which is giving us -10.5071. 5071. The next one is 6.1598. 6.1598 minus 0.004775. 6.1550. Next one is -6.8262 minus 0.004775. -6.8310. 8310. Then lastly, 11.1878 minus 0.004775, giving us 11.1830. Okay, this is what we are going to use for adjusting. So for adjusted or the average seasonal index for the first quarter, we had -10.5071, 6.1550, -6.8310, 11.1830. Repeat the same thing for year 2015, 10.5071, 6.1550, negative 6.8310, 11.1830. And for the last year, negative 10.5071, 6.1550, negative 6.8310, 11.1830. Okay, now let's go ahead to deseasonalize our y values. So we have deseasonalize values or deseasonalize y. How do you get deseasonalize y under the additive model? So it's your actual y minus your ASI. So for the first value, we have 55 minus, but because there's already there's minus here, so it will be 55 plus 10.5071. So we're going to get 55 minus minus, which is giving us positive. 55 plus 10.5071, giving us 65.5071. The next one is 76 minus 6.1550, 69.845. 61 plus 6.8310, 67.831. 77 plus 77 minus, so for here we are having 61, now 67.831. Next one is 77 minus 11.1830, 65.817. 54 plus 10.5071, 64.5071. 65 minus 6.1550, 58.845. Next one is 52 plus 6.8310, which is 58.831. 81 minus 11.1830, 69.817. 59 plus 10.5071, 69.5071. 83 minus 6.1550, 76.845. 78 plus 6.8310. So having 84.831. Then lastly, we have 93 minus 11.1830, 81.817. Okay. So after finding your deseasonalized y values, we need to find another regression equation based on the deseasonalized values we found and this column, that's the column T. So now let's find a new regression equation based on this deseasonalized value. So our first value was 65.5071, 69.845, 67.831, 65.817, 64.5071, 58.845, 58.831, 69.817, 69.5071, 76.845, 84.831, then lastly 81.817. So based on this deseasonalized, our new regression equation becomes y is equal to a, which is 60.1421. Then the b also becomes 1.4397t. So we are going to use this for forecasting our values for year 2017. So for 2017, based on this equation, it was based on the seasonalized value. So any value you are going to find is for the seasonalized. So the seasonalized values for quarter one in 2017 is given as 60.1421 plus 1.4397. Now the T for 2017 quarter one is 13 because we ended here, that's 12. So if we were to continue for 2017, our first quarter for 2017 would have been 13. So now we can easily find the values. So 60.1421 plus 1.4397 times the 13, which is giving us 78.8582. Now for quarter two, 60.1421 plus 1.4397 times 14. Okay, so now we are done finding for the deseasonalized values for 2017 using this equation. Now we need to convert this deseasonalized values to what? You have to seasonalize them to include the what? The effect of the seasonal variation. So now let's seasonalize these values we've gotten. So for the seasonalized values for 2017, so for quarter one is given by the deseasonalized value that was 78.8582. We add the what? The ASI for quarter one plus, let's check the ASI for quarter one. We had negative 10.50, so plus negative 10.5071, which is giving us 78.8582 minus 10.5071, 68.3511. Now let's go to quarter two. The deseasonalized value for quarter two, 80.292974. We add the ASI for quarter two, which was 6.1550. 1550, 80.2974 plus 6.1550, giving us 86.4524. Now let's come to quarter three. The deseasonalized value for quarter three was 81.7376. 7376. Let's add the ASI for quarter three. It was negative 6.83, negative 6.8310, $74.9066. For quarter four, we had a deseasonalized value of 83.1773. 1773. We also add the deseasonalized, the ASI, which is 11.1830, giving us 93, that's 94.3003. So these are the seasonal values for 2017, and these are the seasonalized values for 2017.